Okay, so far we've been working with substitution and elimination, and I want to direct your attention to page 40, where we have been working on the past couple of days with elimination in particular. I'm going to direct your attention specifically to two different questions. 4b, and 4b says it's a linear system that looks like this. 5x minus 3y equals 25, and 10x plus 3y equals 5. And I also want you to look at D at the same time. Its linear system is 2x plus 3y equals 8, and x take away 2y equals negative 3. When you look at both of these equations in the first set in 4b, in this system, what you should directly notice is the 3's in front of the y. Okay, so the coefficients. This is a prime candidate for using elimination when you see coefficients that are the same in front of either of your variables. In this case, it's y. In a couple of examples that we've done before, it's been y. But in this case, it was y again. This system should easily be solved using elimination. When you look at this system, the coefficients of y are different. The coefficients of x are different. But what really stands out is the 1 coefficient in front of x. That 1 coefficient in front of x tells you that in this system, substitution would work nicely. However, you could still use elimination, right? There's still a method for using elimination in this case. So let's take a look at 4b. If we're solving 4b, what we would want to do is add or subtract these two equations to eliminate the variable y. Because these are opposite signs, if we add the two equations, we will eliminate the variable y. So here we go. They're already stacked up one over top of the other. The variable x's are over top of each other, so when we add 5x plus 10x, it's 15x. When we add these two terms of y that have opposite signs, negative 3y plus a positive 3y, they cancel each other out. Equal signs lined up, and here we are adding the two numbers at the end. 25 plus 5 is 30. Now we have another equation where we are simply just solving for x, so I can divide both sides by 15. That isolates x for me. 30 divided by 15 is 2. I tell you to put a box around it so that it stands out, right? And we can do something with that. I'm just going to slide up a little bit here. Once we've found x, we can substitute x back into either one of these two equations in order to find y. And it's your choice which one you're going to use. I typically use the one with smaller numbers or the ones that look a little bit easier to deal with. Maybe that's the second equation in this case. So in place of x, so we have 10x plus 3y equals 5. In place of x, where there was an x in the equation, I'm going to write the number 2. Now I have an equation with only y in it, so I can isolate y. So simplify a little further. 10 times 2 is 20. I can then bring the 20 over to the other side, right, so that I'm in the process of isolating y. So I have this positive 3y. Notice it's a positive, okay? I bring the 20 over, it becomes a negative. And I got to slide up again. So I continue my solving. 5 take away 20 is negative 15. And when I divide both sides by 3, that That cancels out the 3 and leaves y equals -5. And I always tell you to just write a closing statement. Therefore, the solution is x always goes first, so the 2 goes first, the y goes second. Okay? In this next system over here in 4D, we have that one variable or one coefficient out in front, so we could use substitution. I'll go through a substitution question with you again just so it's good practice. So what we'll do is isolate x in this equation. If we're going to isolate x in this equation, we have to bring the 2y to the other side. When we do that, x is the only thing remaining on the left-hand side. On the right-hand side, we have the -3, which is still there. We bring the -2y over, it becomes a positive 2y. Okay, so this is what x is. X is -3 plus 2y. We're going to use that value of x and substitute it into the first equation. You always have to go into the other equation that you haven't dealt with yet. So here we go, 2, and in place of x, we're going to put this amount, plus 3y equals 8. Oops, I don't know what happened there. But -3 plus 2y is what's going to go in the bracket. We have to carry out the distributive property here because there's a number in front of a set of brackets, and the set of brackets contain more than one term. So the 2 multiplies by -3, and the 2 multiplies by this positive 2y to give us positive 4y. We still have the plus 3y, and we still have the equal sign and the 8 on the right-hand side. Now we can just collect like terms. There's no like term with the -6, but there is a positive 4y plus 3y, which is a positive 7y. And I just need to slide. Oops. I don't know how to do this very well. I'm going to just slide it up. I know it's overlapping, but I'm running out of space, and I don't know how to deal with that. So anyway, bear with me for a second. Still isolating y, we need to bring the number of -6 over to the other side. And when we do that, we're left on the left-hand side, we have remaining a positive 7y. On the right-hand side, we have an 8, and we bring this -6 over, it becomes a plus 7y equals 14. And in isolating, I'm going to divide both sides by, by 7. I was looking at the answer. Divided by 7. And I have y equals 2. So I know what y equals, and I've already found what x is, so to speak. It's in this jumble up here, but I'm going to just pause this and fix it up a little bit. Okay, so with the y equals 2, once we found what y is, we already know that x is in relationship with y right here. X is -3 plus 2 times whatever y is. So by substituting it in there, we will do that. X is -3 plus 2 times y, and y is 2. So x is -3 plus 4. We have to do the multiplication here first, right? And now we can add. -3 plus 4 is 1. Therefore, the solution is x goes first, y goes second, and you're done. So there's an example of substitution. And when we would use substitution, particularly if there is a 1 coefficient. And when there's not a 1 coefficient, elimination works best. It works best when there's a commonality, the same coefficient in front of one of the variables. That even works better. Okay, the next video I'm going to show you is is an example of elimination that is a little bit more difficult.